Okay, so now that we're done quickly doing our intro to the intro crash course here, we can talk about some concrete philosophers. And the place that makes most sense to begin in that regard is a group of them called the Presocratics. The Presocratics were a group of philosophers. Well, let me ask you, what does the very word pre-Socratics imply? Before Socrates. What does that imply about Socrates? He's what? Yeah, not the first. He's called the father of philosophy, rightfully so, but he's not the absolute first. What else does it say? What else does the very fact, like, they're not going to call the philosophers before the year 2000 the pre-Daniel O'Connors. Why? Yeah, he's important. Like, I'm not important, which is why, like, no one will remember me. But Socrates is kind of a big deal. So we actually label the history of philosophy in accordance with his life. We call the whole group of them before him the Presocratics. And the biggest philosophers after him, the two biggies, namely Plato and Aristotle, they're really following in the Socratic tradition. But why not earlier? It's not like we don't have records of people thinking about things long before even these Presocratics. So the first Presocratic we'll talk about, Thales. I think he lived born somewhere around 700 BC. 1,000 years before that, 1,000 years before the first Presocratic, the Babylonians were charting the course of the stars with such accuracy that they could predict eclipses. They were incredibly advanced in that regard. But why do we not say that philosophy was born with them? Well, I like to read some excerpts from a volume, a philosophical volume by Frederick Copleston, who was a philosopher, a historian of philosophy as well, who died a few decades ago probably. But he wrote one of the most respectable volumes on the history of philosophy. It's like an 11-volume set. I have the first of them here. And I just like to defer to the input of this great mind, Frederick Copleston, every now and then. And that's what I'm going to do in introducing the Presocratics. I'm going to read a couple things from the book itself, and I also have some quotes here in my own notes from the book. Detailed arguments left aside, let it suffice to point out, and this is Copleston speaking, that Egyptian mathematics consisted of empirical, rough and ready methods of obtaining a practical result. Egyptian geometry largely consisted of practical methods of marking out afresh the fields after the inundation of the river Nile. Scientific geometry was not developed by them, but it was developed by the Greeks. Similarly, Babylonian astronomy was pursued with a view to divination. It was mainly astrology, but among the Greeks it became a scientific pursuit. The Greeks stand as the uncontested original thinkers and scientists of Europe. They first sought knowledge for its own sake and pursued knowledge in a scientific, free, unprejudiced spirit. Greek philosophy was, from the first, thought pursued in the spirit of free science. They were the first, these Presocratics, this group of philosophers called the Presocratics, they were the first to not merely observe what was happening and try and come up with practical methods of using observations and calculations to our advantage. But they tried, they didn't exactly succeed all the time, but they tried to pierce beyond the appearances of things and ask questions about the fundamental nature of the things that we observe. For this next discussion sheet, we're going to go through some of the more famous ones and briefly discuss each of them and how they each tried to come to philosophical conclusions about the very fabric of reality, about the very nature of the universe. And I don't suppose we'll agree with the details of any of their arguments. I'm sure we'll agree with some of the details, but I don't suppose we'll agree with their main premise, their main thesis. But that's not the point. The point is that they were the first to think, to ask these questions that nobody before them had even really bothered to ask. Or at least if they bothered to ask, hadn't vigorously pursued the answers to. So there were a couple of dilemmas that above all stood out to them. And I want to read a brief paragraph to introduce those dilemmas that they were seeking to address. The splendid achievement of Greek thought was cradled in Ionia, and if Ionia was the cradle of Greek philosophy, Miletus was the cradle of Ionian philosophy. It was at Miletus that Thales, reportedly the earliest Ionian philosopher, flourished. The Ionian philosophers were profoundly impressed with the fact of change, of birth and growth, decay and death, spring and autumn in the external world of nature, childhood and old age in the life of man, coming into being and passing away. These were the obvious and inescapable facts of the universe. Think back to where we said this is one of the starting points of philosophy, the obvious, inescapable facts of the universe. He continues, "It is a great mistake to suppose the Greeks were happy and careless children of the sun, who wanted only to lounge in the porticos of the cities and gaze at the magnificent works of art or the achievements of their athletes. They were very conscious of the dark side of our existence in this planet, for against the background of the sun and the joy, they saw the uncertainty and insecurity of man's life, the certainty of death, the darkness of the future." All right. So if anyone has an image of ancient Greeks in their minds, maybe from cartoons, has anyone seen an image of some big fat Greek guy getting fanned with olive branches and eating grapes or something? Yeah. So he's trying to say they weren't like that. They were, in fact, they had it quite hard. We saw a brief glimpse into that in the video we watched last week, if you were here for that. There was a lot going on, and they were very conscious, he's saying, of the dark side of our existence. And when are we most likely to ask the really important questions? When things are going really easy or when they're hard? Hard, I think that's safe to say. Somehow, when things are too easy, not everybody's this way, but I admit it's a temptation for me. The easier things are, the more we seem willing to just kind of ignore those questions that we really know we must address. But crises tend to foist the questions upon us, and that's certainly the case with the ancient Greeks. But back to the questions themselves. There were a couple dilemmas that the natural universe, just the nature of things, foisted upon them that they tried to figure out intellectually, philosophically. Sameness versus change was the biggie. The idea of change, how to explain the nature of change. And the dilemma is this. All right, so here's this is going to be kind of weird, but here's my tankard. And I'm going to do a little trick now. I'm going to change it into a phone. Oops. There's my tankard. And, just change it into a phone. Did I? What? There's nothing behind my back. All right. So even if I was able to, I can't hide my tankard for long because now I need more coffee. Even if I was able to hide my tankard from you for the rest of class, why would you say that I did not just succeed in changing my tankard into a phone? Okay, you can certainly investigate the details of what happened and say that I'm not a magician, I didn't actually do that. Okay, so I blocked your sight from even seeing what was happening, so clearly I was I was up to something. But metaphysically, so certainly employing your detective skills, you would all very easily conclude that I did not change my tankard into my phone. But what didn't happen that would have needed to have happened to validly say that one thing changed into another, that the phone changed, that the tankard changed into a phone? Okay, yeah. Exactly. One thing has to be gone for the change. That which preceded the change needs to go out of being for that which comes out of the change to come into being.
I would say that you have no effect on it, so you didn't even touch it.
Yeah, I didn't even, first of all, I don't even say, even if I hid all the details from you guys, you wouldn't say that I changed the phone into the tankard, but that I replaced the tankard with a phone. What's the difference between changing one thing into another and replacing one thing with another?
Changing the rules that the middle of an object, that one object was
Yes.
the same object, but became its
Yes.
other object. So you wouldn't even have the cup in the first place. It would have been the phone or the cup.
Yeah.
And then it would have changed eventually to being the same stuff.
Okay. So there has to be a continuity of existence to say that one thing changes into another. And that continuity is found in what we call the what of a change. There is a substrate or a substance. If I took this tankard and just in front of you guys just pounded it into a plate, you would probably agree with me that I changed my tankard into a plate, right? Why? Because what substrate carried the identity of existence of that thing throughout time? Yeah, the metal, the pewter of this tankard would have stayed the same in order for the tankard to have changed into the plate. Long story short here, what the pre-Socratics realized was that there's all this stuff changing in the universe all around us. There's constantly this change, and yet the mere fact that we refer to things as changing implies that something is what? That something's not, that
It wasn't that thing in the first
yeah, that it wasn't that thing in the first place, and that underneath all of this change, there is something that is not changing. For anything to change, there has to be something underneath the change which must stay the same. But from that insight, they zoomed out even further and said, okay, what about all of the changes that occur? What if you break down changes? What if you zoom out as much as possible and zoom in as much as possible? Everything, it seems, can change into something else. There's all this change happening at every level. What then is beneath all change? What is, in other words, the fundamental stuff of the universe? The Urstoff. Also referred to as the arch, the principle, the fundamental stuff of the universe. The Urstoff is a German word for it that's often used, but they were all trying to figure out what is that one thing that is beneath all other things, that takes various forms and gives the substance to each of the various things that we interact with. What is that fundamental stuff of the universe? There must be something to give everything's existence continuity and stability. You know, another example, and this is just a simplification of an example referred to as the ship of Theseus that's found in Plato, but I'm going to make it simpler. If I give you an axe, if I lend you an axe and you're just lumberjacking away with this axe so much that you dull the blade and break the handle and you decide you're going to do the right thing and you replace the blade and the handle of this axe and you give it back to me, have you given me back my axe? No. Why? Yeah, there's no what? There's no substrate. There's no substance. There is no axeness. That axe is not a thing that has an identity that transcends its handle and its blade. If its handle and its blade are gone, it's not the axe anymore. You haven't done anything wrong. You've given me something back of equal or greater value. That's fine. But the point is, you haven't given me back my axe, because we don't say that there was even a substrate under that. But in general, there must be something underneath all of these other things that we do say change from one thing into another. If, well, goodness, I don't want to get too ahead of myself. We're going to talk about the substance. The more important questions are the ones that transcend the material questions entirely. We'll get more to that in the Plato unit in a couple weeks. Goodness, but now that I brought up the axe example, I can't help but bring this up. I'll try to keep this brief, though. So in the Plato unit, we'll try and ask these questions the pre-Socratics asked about the more important things, namely human life. But if an axe does not persist beyond its matter, What about you? If you look at a picture of yourself when you're 2 years old, you say what? I look so young. You say I'm so cute. You also say that's what? That's me. You don't share a single cell in common with the person in that picture. All your cells, all the matter of your body, unless you've never cut your hair or clipped your fingernails, there's nothing in common with the person in that picture and with you now. And yet, you rightly say, that's me. What can we conclude from that? Well, that's a quintessential philosophical question. What can we conclude from those givens? But again, sorry, I don't want to get too ahead of ourselves. We'll take a look at that in a couple of weeks in the Plato unit. For now, the pre-Socratics are asking all those questions, not about human life, not about right and wrong, not about the really deeper things, but about the physical universe. And that's a good starting point, at least. So, we begin with Thales. Copleston has a few more words that I usually like to share, but for the sake of time, I'm going to skip them. So the first of these pre-Socratics, if you were a pre-Socratic almost 3,000 years ago and you looked out upon the world and had to decide of all the things you could see, what is that one thing that might be so very fundamental and ubiquitous, universal, necessary, seemingly infinite, that maybe it itself is the substance that is beneath all other substances, especially if you live in the Mediterranean basin. Yeah?
Water.
Water. Thank you. Water. So for Thales, it's water. Now, I have to pause here. Remember, the whole point of these pre-Socratics is that they're well aware that they are asserting things that seem to not be so. Thales is not stupid, as you'll see in a moment when I talk about some other conclusions he came to. Thales was an incredibly intelligent individual. He is well aware of the fact that a piece of wood does not look like water. That's the whole point of these pre-Socratics. They're trying to pierce beyond appearances and make conclusions about the invisible and fundamental metaphysical nature of things. They intuitively grasped, they logically grasped, that there must be some sort of a substance underneath all changes. They realized that whatever that substance is, it's not immediately obvious to the senses. So whatever they conclude, yes, there's going to be some degree of suspension of disbelief. There's going to be some degree of it not seeming to be the case. Doesn't mean we have to agree with them. Of course, we're not going to agree with Thales that everything is water, but it does mean that we shouldn't just write them off as stupid. They were incredibly intelligent people. Thales, above all, seems to have proven his merit in many ways. He was rightly regarded in those days as quite a genius, quite a sage, for a number of reasons that people could even see in his own day. He was able to predict all sorts of things by his own astronomical observations. He, it is said, this was the one who first discovered exactly how many days are in a year. Now, how would you go about discovering how many days were in a year if you didn't already know how many days were in a year? Well, that's exactly how we did it, yes. It's quite an insight, though, when that hasn't yet been known. When you just have to, generally we all know that a year is like about a cycle of seasons. And if you want to know how long a year is, you can say, okay, it's pretty hot now, I'm going to wait till it gets pretty hot again, count the days until that happens, and that's a year. That won't be very accurate, will it? But if this were a year-long course, I could just say, I'm going to reserve this side of the chalkboard for our measurements. At the very beginning of each class, some classes this works so well because of the way the sun beams in. It leaves a perfect line on the chalkboard. And I could just trace that line at the very beginning at the same time of every single class. And what would that line do? Yeah, it would change bit by bit each class, and then it would start going back until all of a sudden it's exactly the same. You can measure the angle of the sun with any shadow. So that's all Thales had to do. He with his careful measurements of the angle of the sun, he calculated that the year is 365 days. But he didn't stop there. he was able to calculate all sorts of things. The video we watched last week pointed out one of the things he did. He was able to measure the heights of objects by just measuring the shadow of something that you already know the height of, and you can very easily anytime you want to know the height of something, all you have to do, you all know how tall you are, just measure your shadow, and then whatever proportion your height is to the length of your shadow at the same time of day, that's the same proportion that everything else is to its own shadow of its height.
Is that how they created
The pyramid, yeah, the Great Pyramid, yeah. But he didn't do just that. He figured out how big the Earth was also. Using a very simple. This one was a little harder, and I can't remember the details of this geometric proof, but I did go through it. I remember in one of my geometry classes years ago. It took a year to do it because he had to go to different cities at the same day. But after knowing how long a year was, he could do this, measuring the cities far enough apart, the same time, the same day. He could compare the angle of the shadow to one to the angle of the shadow in another, and discover this chord, the chord being a partial diameter, basically, of this circle, which he theorized to be the circumference of the Earth, and of course he was right. And knowing that chord enables you to figure out the radius, and then you can very easily calculate the circumference from that. He was quite accurate. He got it incredibly close, just from his own theories about the angle of the sun. He did a bunch of other things as well. I don't want to go through them all. A couple of interesting things that I can't help but say. So everything for him was water, and we can obviously see how much sense that would make as the first of the pre-Socratics Urstoffs to theorize. Water, not only is it necessary for life, and is incredibly vast, but even more substantially, water is the only substance that under ordinary conditions, in ordinary day-to-day life, water is the only substance that can do a certain something, that can be a certain something. Exactly. Now, we now know that just about any substance can be forced under the right lab conditions to do that, but that's only so relevant. Water, correct me if I'm wrong, but I can't think of any other substances that under the conditions that one will see in ordinary life, can be either a solid, a liquid, or a gas. Water, of course, we all see as all three all the time. Now, why is that particularly profound when one is trying to ascertain the Urstoff? Well, the whole point of the Urstoff is that whatever it is, the same substance is capable of assuming radically different forms. It's exactly what water does in its three phases. I should say it's exactly what H2O does in its three phases of water, ice, or vapor. It's the same substance, it's still H2O, and yet liquid water is so different from ice, which is so different from vapor. Same substance underlying very different changes. So it really makes a lot of sense that he would think this. Now, of course, he was wrong, but we give him a lot of credit. Not all things are water, but to his credit also, water is in almost everything to an extent that you would never guess just by looking at it. Does anyone know what percent, just a piece of fruit is water? It's almost all fruits and vegetables are between 90 and 99% water. Almost never, if you break it apart and squeeze it, you'll discover that, but you wouldn't just know that just by looking at it. So water is incredibly ubiquitous. Thales also had very mystical views on water, though. It was alive. For Thales, in fact, everything is alive. Thales also discovered, why did he think everything was alive? Well, something he discovered is going to give a clue to that. Well, everything, in other words, had a soul. Everything was living for Thales. Not just humans, not just animals, not even just plants. Everything was living. What is the most obvious proof of motion? I just gave away the answer. What is the most obvious proof of life? Motion. It's not an absolute proof, but it's the easiest and most obvious proof, at least. When you're a parent, you will spend a lot of your time trying to figure out if your kid is sleeping or dead. And they're always sleeping, just leave them alone. But if you really want to know, the easiest way is just to kind of look at their chest, and you can always see it rising and falling a little bit if you line it up with something stable behind them. So we always look for motion when we want to discover that there's life there, but how? Okay, so why is this not alive? It didn't move. How? It didn't move by itself. It didn't move under its own volition. What seems to contradict that principle and yet is not alive? Although, Earth, okay, wind, yeah. Water, certainly. It seems to have this mystical motion there that we can't necessarily always explain, especially with the waves of the sea. Even more fundamentally, though, there's something that if you didn't know the principles behind, God bless you, behind which it operates, you would think it's alive. It's not a Mexican jumping bean. Oh, those are alive, right? Like, those are just bugs, right? I don't know. We're going to talk about that in just a minute. That very much seems alive, in a very startling way, actually. Magnets. A magnet seems to move under its own volition. It's near something metal or another magnet, it just moves. Now, we of course know now that magnetism is just one of the fundamental forces of the universe. Doesn't prove that something is alive. But guess what? Thales discovered lodestones, which are naturally occurring magnets. This guy just couldn't stop figuring out awesome stuff. And somehow he discovered lodestone. And with all these ancient Greeks, you never know for sure what the person himself literally did or what legend described to him. But frankly, I don't really care. I'll just go by it. It doesn't really make a difference. But I think it's tenable that he would also discover those with how very inquisitive he was. So lodestones are magnetic material naturally occurring in the Earth's crust. He discovered those. Those clearly were moving under a force he did not understand, so he concluded that they too, like everything else, were alive. All right. But we probably don't want to agree with him. Because as much as you squeeze a rock, you're not going to get water out of it. So we have to keep trying to figure out the Urstoff. And his student, Anaximander, had a different idea. And the interesting thing here is that Anaximander was one of the earliest pre-socratics. I mean, he was right there with Thales. He was a student of Thales. And yet, his proposition went way beyond the state of things at his time, and people didn't really get back to his level for quite some time after him. So Anaximander comes after his teacher Thales and says this. He had a simple syllogism, and went as follows. The basic substance stuff of the universe underlies all change, and therefore it cannot change into something else. But all of the elements that we observe, water of course being one of them, do change into others, Anaximander says. He concludes from these two premises that the basic substance stuff of the universe cannot be any one of the elements that we observe. Now, the logic is actually valid, but his premise is not absolutely bulletproof. He didn't exactly prove that everything can change into something else. That's kind of circular. But anyway, still, he was very much onto something. Basically, he's saying, look, any of the individual things we see, if it were the fundamental substance stuff of the universe, whether it's water or whatever else, then it would be infinite. But if it's infinite, it would, extinguish all other things. Nothing else would be able to exist in contradiction to it. So clearly, whatever substance stuff of the universe there is, it must itself be something that is not perceptible. It must be so very deep and fundamental that our senses have no access to it, and we cannot see it directly in any one of its forms. So what does he do then? If he says that we cannot even describe it, he calls it the apeiron. The substance stuff of the universe for Anaximander is simply the indeterminate, unlimited stuff. And that's really all you can say about it. It is some one thing, but we cannot know that some one thing. for Anaximander. This is actually a similar line that Aristotle took hundreds of years later, saying that at its most basic essence, all matter can only be said to be prime matter. If you boil anything down deep enough, it is this prime matter. But prime matter is not anything perceptible at all. So Anaximander is kind of agreeing with Aristotle long after. But many more things had to happen before then. Anaximander says it is neither water nor any other of the so-called elements, but a nature different from them and infinite, from which arise all the heavens and the worlds within them. It is a substance without limits, eternal and ageless, and it encompasses all worlds. Now, along with this view that everything is the apeiron, Anaximander had some interesting cosmological speculations. Here's what he says. There is a plurality of coexistent worlds which are innumerable. Each is perishable, but there is an unlimited number of them in existence at the same time, worlds coming into being through eternal motion. The world as we know it was formed by a vortex of movement, the heavier elements remaining at the center of the vortex, the lighter elements going towards the perimeter of it. So whatever this apeiron is, it's swirling about eternally, infinitely. And within this swirling apeiron, there are infinite universes coming into being and going out of being. And our universe is just one of those infinite universes. So there's this universe, as we now know it, as it is here. But then there's also a universe where this eraser, instead of being right there, it's right there. There's infinite others. It's a universe where every possibility is realized. I don't know anything about this, but some years ago I had a student say, oh, so Anaximander was the first one to come up with string theory. Maybe. I know nothing about string theory. But it has been said that there's nothing new under the sun that has not been posited first by the ancient Greeks, and whoever said that was onto something, because it does seem like they thought of everything. Not all the details of it that we come up with today, but the gist, perhaps. All right. I'm not sure what else we can say about Anaximander, though, because of how very vague he intentionally keeps his apeiron. So we move on to the next. Anaximenes. At this point, you are all probably very thankful that the final exam is open notes. Because for the life of me, I still can't keep Anaximander, Anaximenes, and Anaxagoras straight in my head. So I hope I'm keeping them straight in my lecture here. Anaxagoras is the last one on your sheet, I think, or the second to last maybe. But Anaximenes is early, and he kind of rejects the progress that Anaximander made in this question and instead ascribes it to being one of the elements that we observe. The doctrine of Anaximenes appears, at first sight at least, to be a decided retrogression from the stage reached by Anaximander, says Copleston. For Anaximenes, abandoning the theory follows Thales in assigning abandoning the theory of the apeiron follows Thales in assigning a determinate element as the Urstoff. Not water, but what? What else is so necessary, so vast, so fundamental, that perhaps it is the essence of all things? Air. Can't blame him. It is indeed quite vast. We need it. It's necessary for life. Anaximenes maybe gets the least credit of all, though. And I feel a little bad for him because, people think Anaximander is awesome because of this. And they expect people to, the next guy to really take it further. Instead, he just goes right back to saying it's one of the elements. But I think he deserves a little more credit than he gets. Because he introduced a secondary notion on top of his Urstoff. And he said, okay, he actually tried to give an explanation for how it is that air assumes all of these different forms in order to explain what we observe. Thales didn't so much do that. It's just everything's water. It's quite plain and simple for Thales. But for Anaximenes, air is either extremely condensed, and when it's extremely condensed, it becomes water and then earth and then rock. And when it's extremely expanded, well, in its ordinary state, it's air as we speak of it ordinarily. But when it gets even more expanded, it becomes fire. So he has this explanation to at least attempt to make sense of the variation we see in air. But still he deserves more credit because we don't necessarily intuitively grasp just how much is in the air, just how much air is to thank for the existence of things. When a plant grows, where is it coming from? So it's got its roots in the ground, and it's certainly drawing up water through its roots. But where is the mass, the majority of the mass, matter of that plant actually coming from? What's that? Sorry?
CO2?
Exactly. Which is where? In the air. A lot of people don't realize that plants materialize out of thin air. It's just very gradual, so you can't see it happening. The vast majority of the mass of any plant is from the CO2 in the air that it stores, as you all learned in high school, through photosynthesis, as carbon within its mass. To Anaximenes' credit, this substance of air kind of does morph into all sorts of other substances that do not appear to be air at all. Now, there's all sorts of other processes on top of that we certainly can't give Anaximenes credit for explaining, but still. And the reverse is true as well. You know, if you really want to completely get rid of something, what is the most thorough way to get rid of it? Burning it. So where is it going? So what does what's the relationship between the matter of the ash of a thing and the thing before it was burned? What's the difference there? What's that? Major volume difference. It didn't really become ash. The ash had just left over. It really became air. And you can't even say it became smoke because in a good combustion process there won't even be smoke. There won't even be visible smoke. A few years ago I had to heat my house with wood because my boiler broke. And as an adjunct philosophy professor, I certainly cannot afford to just replace my boiler when it decides to break, so I just had a wood stove and I was heating my house with wood. I had to buy like 10,000 pounds worth of wood. Wood is pretty cheap though. And it was this huge pile in my driveway. And at the end of the winter I had gone through it all, and all of the ash that was produced from that huge 10,000 pound pile of wood fit into like a couple small bins. So where did all that other wood go? It disappeared into the air. It was in the air. And it'll just become another tree at some point when some other tree absorbs it. So air really is this material vat of existence in a way that Anaximenes certainly didn't fully comprehend, but he was on to much more than he gets credit for. Air as a quasi-Urstoff makes a lot of sense, even though, of course, he's not literally correct. All right, what else does he say? Here's Copleston here. There's an obvious difficulty in explaining how all things come from air, and it is in his proffered solution to this difficulty that Anaximenes shows a trace of genius. In order to explain how concrete objects are formed from the primitive element, he introduces the notion of condensation and rarefaction. And I already talked about that, but just to reiterate that we have Anaximenes to thank for the very notion of the ability of a given substance to be condensed or rarefied. Rarefied is a term not used too much today for expanded. If something is very expanded, it is rarefied. And air, of course, can do that. Air itself, without necessarily changing forms, well, anybody been to Denver? What did you notice when you went to Denver?
It's really low altitude, high altitude.
Yeah. Yeah. Same thing happened to me when I went on a simple walk and I was out of breath. The air is so much more thin there that you need a lot of time to get accustomed to it. And it's simply because the same air is rarefied and it interacts very differently. You have to cook things for different amounts of time there and all sorts of stuff. Anyway, moving on, things change up a lot with our next guy here, Pythagoras. Here things start to get interesting. He's not just picking another element out of he's not just picking another visible element out of a hat and saying everything is fundamentally this. He's changing up the question entirely. Let me do some erasing real quick here. So you guys probably all know Pythagoras already from the theorem that is justly named after him. Pythagoras is shrouded in legend, certainly, but I'll spare you all of the details and what might and might not be from him, and we'll just assume the legends are true, because why not? Although some of them are just too absurd. It is said that first of all, he was not just a philosopher, he founded a kind of a religion almost, kind of like a school / religious order / mystical cult type thing. His followers said this is really random, his thigh was made of solid gold. Probably wasn't, but that's what they said. He had all sorts of interesting doctrines that you had to follow to be a member of his Pythagorean society. And at the heart of all of this mysticism was his Urstoff. And knowing what you already know about Pythagoras, let me ask you what you think he said all things were. Close? He was all out matrix. Everything is just number. Everything is number. Now, I'm not saying he was solipsist. He wasn't saying we were all numbers in a hard drive. He didn't know. There wasn't a thing as hard drives back then. He was saying everything is literally number. All those fictional is everything a simulation speculations. Those aren't saying everything is literally number. They're saying everything is literally hard drive. And then there's someone else who has the hard blah, blah, blah. But anyway, Pythagoras is saying that the very essence of things is fundamentally number, which is very difficult to wrap one's mind around what he even means by that because of the approach that we take to number today. And obviously, I'm not saying Pythagoras is right. But as usual, I want to give these guys a little more credit than they get at first glance, because we have the extreme opposite view of number today than Pythagoras had. Today, we are very nominalist when it comes to everything, but certainly numbers. And this is evidenced in many ways, but I remember being particularly annoyed when I was teaching 10th grade math, 11th grade math, and I can't remember which, and the textbook introduced a certain type of number. Okay, well, what type of number maybe blew your mind in 11th or 10th grade when you were introduced to it? Imaginary. What, was your mind blown by something else, some other type of number? Irrational. That's mind-blowing as well. Imaginary may be even more mind-blowing, but here's what the textbook did that I was teaching out of, and it annoyed the heck out of me, and Pythagoras, he would not have liked this. It said, so after introducing imaginary numbers, the textbook said in parentheses, as if to make a cute little consoling remark to the student, but don't worry, all numbers are imaginary anyway. What would Pythagoras do if you said that to him? He'd take you out. But here's the thing. We're kind of primed for agreeing with that because, in fact, we were not introduced to imaginary numbers in 10th grade or 11th grade. We were introduced to imaginary numbers in 6th grade. But they weren't called imaginary numbers. They were called what? Negative numbers. Now, I have no problem with negative numbers or imaginary numbers. They're very useful tools. But if you have 5 apples and you take 7 apples away, how many apples do you have? You can't take 7 apples away from 5 apples. There are no apples left if you quote, take 7 apples away from 5. Here's the thing. Whenever we use a negative number, we are not asserting something about reality in the same way we are when we use a positive number. You don't need to interpret what is meant by 3 apples. 3 is an essential quality of nature. I'm not going to go as far as Pythagoras and say they're literal substances. I don't think he's right about that. But today we have the extreme opposite nominalist view that they're pure fictional entities that we merely imagine. We'll talk about nominalism more later in the Plato unit. But this is just a brief preview. So what do we mean when we talk about a negative number? Well, that negative sign is just a placeholder. It's just a symbol that some sort of a meaning has to be read into to understand what it means in a given context. Number itself is not that way. Number itself, sure, can apply to all sorts of different contexts, but it bears its own meaning within itself. It doesn't need a superimposed meaning. A negative sign always does. If you have negative $3 in your bank, what does that mean? Yeah, it means you owe $3. If you're going negative 3 miles an hour, what does that mean? Yeah, you're going backwards 3 miles an hour. That negative, this is just a mark that means something in each context. It's not a number, God bless you, in the same sense of the word that the positive number is. So I just bring that up because I think the way we do math today is completely devoid of philosophy. We use it as pure pragmatic calculation so we can be better computer programmers later or something. And look, we do need to be pragmatic, don't get me wrong, but we shouldn't abandon philosophy in the process. This number has a truth to it. Number has a reality to it. And there's a difference between discovering something and inventing something. And figuring out when we're discovering something and when we're inventing something and being very honest about the distinction is key to good philosophy. So Pythagoras, we have a lot more to thank him for than just the Pythagorean theorem. He came up with a few other things as well with numbers. Square numbers. I can't help but mention a few other things about this. Why do we call them square numbers? Yeah, they're the product of the same number times itself. Why on earth do we call them squares? They're numbers, not shapes.
The square has two
Yeah. This gets to the essential nature of number. Okay, so sometimes we're talking about the essential nature of a number, and sometimes we're talking about just the symbol for a number in a given language. What have I done? This is separate. What did I just write? This is weird. I don't know if anyone will know this. This is binary. Any programmers?
No.
But the thing is, this is hex, and this is a difference. F minus A would be 5 in hex, but hexadecimal. The point is, this is all the same. You often hear people say, "Oh, that this same thing is expressed in so many different ways," and sure. Just because a reality is expressed with different symbols doesn't mean there isn't a reality underneath the different symbols. This is 5, this is 5, this is 5, this is 5, and this is 5. The different symbols are the same essential reality. When we're talking about a number as a square, we're talking about the reality underneath the symbol. So a square number, what's the most basic way of representing quantity? Having that number of things. If you're by the beach, you have a lot of pebbles, you want to represent number, you'll just lay them out on the beach maybe. So if you have 4 pebbles, what can you make with 4 pebbles? A square. What can you make with 9 pebbles? Another square. You can always make a square out of a square number. This is a reference to the reality. So this is Arabic, Roman, tally marks, decimal, hexadecimal, again, all just different languages for the same reality. Just like cat is a reality, even though in Spanish we call it gato. Still the same, there's still a thing underneath the symbol. Nominalism says that's not true. There are only symbols and nothing more. That there are, but anyway, I don't want to spoil the fun for when we get to that unit. But suffice it to say that Pythagoras is an anti-nominalist when it comes to number. For with anything else, I don't know. But for number, he's an extreme anti-nominalist. He goes to the extreme opposite end of the spectrum and says that numbers are literal substances. And again, I'm not going that far. I'm saying they're real, but not that they're real, not that they're substances. But anyway, everything is essentially number for Pythagoras. And this is also a mystical truth, a very musical, mystical type thing for Pythagoras. The Pythagoreans were big into music. Why do you suppose they were big into music? I can't describe the music theory details of this, but I know enough to at least know that music is very mathematical. What are harmonies? I mean, even if you don't know what harmony is in terms of the music theory details, harmonies sound what? Good. It's that simple. They sound good. Like, you don't have to know anything about music theory to know that harmonious notes sound so beautiful, objectively, and discordant notes are not. Even if you know nothing about music theory. And yet, there is a mathematical truth to that. Harmonious notes are perfect multiples of each other if you were to pluck a string of a given length that corresponds to the wavelength of the note. The Pythagoreans realized that. The waveform themselves, their nodes line up because their lengths, again, are perfect multiples of each other. So everything was mathematical for the Pythagoreans, and everything was musical, and the order of all things could be discovered through mathematics for them. They're famous for a particular view that I find fascinating. And it certainly can't be proven, but I see no reason to doubt it either. Anyone ever looked at the inside of a music box? What do you see? What does it look like? Oh, sorry, I thought you said I have seen it. You didn't. I mean, like those old school wind-up ones.
Yeah.
What's inside those?
There's like tumbler.
Yeah.
That has little dots in you.
Yeah.
Comb that has different lengths, but eventually it all reaches that tumbler.
Right.
Take some of the tumbler, take each of the strings of the comb.
Yeah.
Makes it different. It's kind of fun.
And it sounds so nice, and it's just. But if you just open up a music box and look in it and look at that tumbler, it'll just look like a bunch of random bumps on a cylinder. But then it just starts rotating a bit, and this beautiful music comes out. Well, what in the world, what in reality looks like that on a very grand scale? Stars. Stars of the night. Maybe we'll be fortunate enough to see some when we leave shortly. That meant something for the Pythagoreans. They believed that there is a literal music of the spheres. The motion of the heavenly bodies generates music. We can't hear it, but through philosophy we can for them. The idea of the music of the spheres, I believe, traces back to them. It could maybe even further, but they were certainly big into it, and it's had a lasting influence. That the motion of the heavenly bodies actually generates music. The perfect number for them was 10. They believed that every significant thing had to come in groups of 10. Obviously, we can see the importance of 10, but they were particularly fixated upon it. Anyway, let's move on from Pythagoras, as interesting as he is. Actually, one more thing I should say about him. In his kind of religious order / cult, because it was kind of weird, among the many rules you had to follow, one of them was you could not eat meat, because if you were to eat meat, you might just be eating what? Because of a certain doctrine that also goes back to them philosophically. Yeah, of like your friend or something who died recently, reincarnation. The Pythagoreans philosophically posited what's called we call it reincarnation. We're thinking about maybe Hinduism or something, but philosophically it's often referred to as metempsychosis, the transmigration of the soul. The Pythagoreans were big into that when you die, your soul could be put into another human body, or you could be unfortunate enough for it to go into an animal. And if you go about eating meat, you might be eating your grandfather, and you wouldn't want to do that. So no eating meat. You also couldn't eat beans, because he didn't like the shape of them. And that had nothing to do with souls. It just didn't like the shape of beans. So I don't know why. There's just something very unmathematical about the shape of beans, I suppose. Number of other rules, but anyway. These mystical societies in ancient Greece, it's often hard to find out details about them because they were intentionally shrouded in secrecy. Some of them were so secretive that you could not know anything about what happened within their walls, and you couldn't even really say you were a member of one. There are theories that, and I mean this is well into the realm of wild fictional speculation, that these societies still exist. I'm not a member of one, don't but and they still exist. They're still just as secretive as they were 3,000 years ago in ancient Greece, and we still don't know what the people in them do. Who knows? Anyway, let's try to squeeze in one or two more. Heraclitus comes and perhaps makes things even more interesting still. Not to be confused with Hercules. I don't think Hercules had an Urstoff. Heraclitus, however, does. Let me do some erasing. Heraclitus is one of the few pre-Socratics who's still quoted to this day. He had all sorts of biting remarks. You can look up some of his one-liners. Some of them are very well said. Something he's often quoted for, though, is, "You cannot step into the same river twice." And this harkens to his Urstoff. First of all, what is that supposed to mean? You cannot step into the same river twice. Why can't you step into the same river twice? Yeah, it's as soon as you take your foot out and step in again, it's what? It's different water. You can even say it's a different river. For Heraclitus, that's just an image for all reality. All reality, in its fundamental nature, is nothing but constant change, constant flux. So much so that he ascribes that to be his very Urstoff. All things are flux or change. But there's much more to it than that. He also has a kind of an element to put on with that. And I'll get to that in a moment. I want to take a look at a quote here. But before I read this quote, what do you suppose he ascribed to be his Urstoff to go along with this idea that everything is flux or change? What is visible to the senses, not as concrete as water or air, and yet seems to have its very nature be constant flux and change? What's that? Close. Related. It's also very mystical. You know, you can sympathize with Thales. We all feel mystical when we look out in the water, over the ocean. But what else do we feel mystical when we look at? Fire. Fire has, as its very nature, this constant state of change, of tension, of strife, of devouring even, conflict. That is the essential nature of everything for Heraclitus. For Heraclitus, as for the Stoics of later times, I'm reading a quote from Copleston here, who borrowed the notion from him, the essence of all things is fire. Now it might seem at first that Heraclitus is merely ringing the changes of the old Ionian theme, as though because Thales made reality to be water and Anaximenes air, Heraclitus simply in order to find something different from his predecessors fixed on fire. But there was something more in his choice of fire than that. He had a positive reason, and a very good reason for fixing on fire, a reason bound up with the central thought of his philosophy. Sense experience tells us that fire lives by feeding, by consuming and transforming into itself heterogeneous matter. Springing up, as it were, from a multitude of objects, it changes them into itself. And without this supply of material, it would die down and cease to exist. The very existence of fire depends on this strife and tension. This is, of course, a symbolism based in the senses, but of a genuine philosophic notion, and it clearly bears a relation to that notion that water or air will not as easily bear. Thus, Heraclitus' choice of fire as the essential nature of reality was not due simply to arbitrary caprice on his part, nor merely the desire for novelty, to the necessity of differing from his predecessors, but was rather suggested by his main philosophic thought, that things are in a constant state of tension, strife, consuming, kindling, and going out. Everything is always changing radically for Heraclitus, so much so that you can't even identify anything stable underneath them, except if you want to call it fire, or flux, or change. Constant strife, tension of opposites, unity of opposites. He's also known for saying the way up is the way down. And he's on to something in some regards. He also misses things that it took until Aristotle to really clarify. One of the key things that was both an insight but also a mistake was his view on the unity of opposites. Now, it's true that there is a unity of opposites, but the nature of that unity differs from one type of opposite to another. Aristotle, you don't need this down, but Aristotle distinguishes between relational opposites and opposites of privation. And this is so important. I know it seems just so abstract, but you'll see why this is so important in a moment. Heraclitus says that all opposites are completely one, and he's right with some of them. Define left. Opposite of right. Can you define it directly? How else can we define left? We can't. There's no way to define left except by opposing it to right. So you can honestly say that left has no existence except by virtue of its opposition to right. And that's fully valid. There's plenty of other ways to define left, but all of them boil down to just opposing them to something on the right. But here's the thing, Aristotle pointed out hundreds of years later, not all opposites are like that. There's also opposites of privation. And they don't have the same relationship as opposites of relation. So, left cannot exist without right. But what's the opposite of light? Dark. Now, Nietzsche famously takes Heraclitus' notion of the unity of opposites, and he applies them to good and evil. Opposite of good, evil. Left needs right, good needs evil. Nietzsche concludes, to be more good, one must be more evil. And then hundreds of millions of people die. It's too bad Nietzsche didn't read Aristotle. I don't think he did, because Aristotle points out opposites of privation are not of that sort. Light as the opposite of dark, for example, does not require dark to exist, but dark does require light to exist because it is the privation of light. I can only even refer to a given shadow. I'm looking for a nice clear one on the wall here. I can only even refer to a given shadow by pointing to it and defining it in relation to what? Yeah, I can only even say that shadow exists by pointing to this outline of light that's around it. So a privation only exists by clinging to the presence of the thing to which it is opposed, but that's not the case with the light. The light doesn't need any shadow to be identified as light. It doesn't need any whatsoever. So, just a little tangent there. Maybe we'll get more into something like that later. But anyway, Heraclitus, as insightful as he was, can be kind of dangerous if you misread him. But still, we haven't gotten to his most important idea. Before we get to that, and we'll end with Heraclitus, don't worry. A couple words on fire. Fire is worthy of admiration as an Urstoff, also because it's very difficult to say why it's not alive. I don't think any of us suppose that fire is alive, and it's not. But it's still hard to say why it's not, because if you look at the 7 characteristics of life, I had to write them down in my notes because I don't recall them from my bio class, but when you take bio, you are taught 7 characteristics of life. Anyone remember them? Motion, reproduction, sensitivity, nutrition, excretion, respiration, growth. Fire has all those. Certainly moves, reproduces, copies itself. Sensitive, meaning it reacts to stimuli, it certainly does that. Nutrition, it converts material into its own energy. Excretion, gives off ash. Respiration is the very process that combustion undergoes. In growth, it certainly grows. So fire is like this mysterious quasi-alive thing that's not actually alive. And really, of all of the wrong Urstoffs, this is probably the most fascinating. So it also is bound up with a much more, as I said, a much more important idea that we thank Heraclitus for. It's called the Logos. This comes above all from Heraclitus. And this is what we really want to apprehend, the Logos. I brought up Logos in the very beginning of this class because it is the Greek word that is the root of ology. And recall that an ology, coming from the word logos, is a study of something presupposing it is an ordered whole, and that order, that reason, is embedded within it, that order is embedded within it, and it can be discovered by reason. Heraclitus says this logos, which is certainly bound up with his Urstoff, is kind of almost like a quasi-Urstoff itself. It is this order behind all things. Let's see what he says about it. Or let's see what an encyclopedia article says about it, about him speaking about it. It is in Heraclitus that the theory of the Logos appears for the first time. It reappears in the writings of the Stoics, and it is especially by them that this theory developed. God, according to the Stoics, did not make the world as an artisan does his work, but it is by wholly penetrating all matter that he is the demiurge of the universe, penetrating the world as honey does the honeycomb. So intimately mingled with the world that fire is ignited in air, and as much as, sorry, I'm misreading this. This God, so intimately mingled with the world this fire ignited in air, inasmuch as he is the principle controlling the universe, he is called the Logos. This Logos is at once a force and a law, an irresistible force which bears along the entire world and all creatures to a common end, and an inevitable and holy law from which nothing can withdraw itself, and which every reasonable man should follow willingly. So this idea of this Heraclitus, it's a religious idea, as you can see, but not really. It's this idea that there is this actual order that governs how everything inanimate works, and that places demands upon how every living thing must live. And that the irony of free will is that unlike this, piece of chalk which must obey the Logos by falling when it's dropped, any being with free will can discover the Logos with reason and correlate his life to it, or contradict it. And yet the duty that foists itself upon all is to discover this Logos, this order behind nature, and to align one's own life with that order that he discovers. So this idea of living in accordance with nature is a big tenet of Stoicism, which we won't have time to talk about in this course, but it's this idea that there is an inherent order in all things, and the good life is the life that consists in always living in accordance with that order that one discovers. And again, we thank Heraclitus for that. So, very interesting fellow, this Heraclitus. All things are fire, all things are strife, all things are tension, but there's also this order that is called the logos, that is behind all things, that you can discover with reason, and that once you have discovered, must become your law of life. You can perhaps see why he's among the most still quoted of the pre-Socratics. You'll still see him quoted to this day. But we are not done with the pre-Socratics. We've got more interesting things to learn from them, but let me let you guys go because it is late, and we'll pick up with Parmenides on Wednesday. So last class we spent most of the time going through the pre-Socratics' various thoughts on what the fundamental stuff of the universe is, and why need there be a fundamental stuff of the universe at all? Well, they observe something happening, namely change, and they intuitively grasp that something must be underneath all of this change, whether that something is water, air, fire, or something else. They're all trying to determine what that something is underneath all of this change. And I just realized I forgot to pass out the attendance sheet. So this will be my usual routine in the beginning of class, to pass out an attendance sheet, just jot your name down on it. Last class, don't worry, I already wrote down all your names for last class. What would throw a wrench in the works of all of this pre-Socratic, and all of these pre-Socratics undertaking, though? Well, what if the very change that they were all trying to explain metaphysically didn't exist? What if there was no change? And as odd as that might sound, that is precisely what the pre-Socratic Parmenides argues. And I believe he's the next one on your sheet that we haven't gotten to yet. Am I correct? Okay, Parmenides, actually. Parmenides. Let's take a look at what he said. Parmenides' doctrine in brief is to the effect that being, the one, is, and that becoming, that is change, is an illusion. So, Parmenides says there is no becoming, there is only being. Becoming is that process of change, and it doesn't actually exist according to Parmenides. It is pure illusion. He says, for if anything comes to be, then it comes either out of being or out of not being. If the former, then it already is, in which case it does not come to be. If the latter, then it is nothing, since out of nothing comes nothing. Becoming is then an illusion. Being simply is. Being is one, since plurality, multiplicity, is also an illusion, according to Parmenides. Now, I know this sounds strange, and well, it is strange, but let's try and understand a bit more what he's saying here. As far as his Urstoff is concerned, remember the point of an Urstoff is to identify what that something is that underlies all change. So you can't really have a similar Urstoff as the others if there isn't a change under which for there to be an Urstoff. Whoops, got an extra S in there. Sameness / changelessness. This is referred to as the Parmenidean one. You'll see that referred to every now and then. The Parmenidean one. Everything, Parmenides has this idea that all reality, the entire universe, is simply this: a homogeneous, finite, perfectly uniform sphere. And that is it. That is all that there actually is for Parmenides. Everything but that is our senses fooling us into thinking that there is something other than just this one. But why is he settling on this strange notion? Well, he does have a valid point, and the point is this. Here's his argument summed up in a simple syllogism. He says the concept of non-existence is impossible, but the idea of change requires the concept of non-existence. Therefore, change is impossible. Well, why does change require the concept of non-existence? Well, for any change to occur, whatever came into being through that change must have what before that change? Changed and not existed. So if the very concept of non-existence is impossible, then everything that requires it is also impossible, Parmenides says. It almost sounds right for a moment, but he missed a simple distinction where a thing can be impossible, but the reference to it is not impossible. Non-existence, you cannot ascribe something to non-existence, but that doesn't mean you can't refer to non-existent things. I mean, we all know that we could refer to a square triangle, and that doesn't call it into existence just by referring to it. It's just a meaningless name. There is no square triangle, but anyway. Maybe you're not too convinced by Parmenides, and maybe not too many people are, but more convincing than Parmenides was his disciple Zeno. Zeno really liked Parmenides and really liked his idea that there is no change. And he came up with paradoxes. And I'm not going to test you on the paradoxes, don't worry, but I can't help but run through a couple of them because they are interesting. Has anyone heard of Zeno's paradoxes before? It's one of those pre-Socratic things still brought up every now and then. Zeno wanted to prove that Parmenides was right, so he wanted to prove that there is no change. And what's the most obvious type of change? You open your eyes and you see what? The sun, you see clouds. What if you're inside? No matter where you are, whatever type of setting you're looking at, that setting is probably, something in that setting is probably moving. If you open your eyes in the morning and nothing moves for a really long time, that's a problem. Hopefully that doesn't happen too often. Something's going to move. Motion, in fact, is the most obvious of those so-called inescapable facts of the universe. We talked last class about how philosophy must begin with the inescapable facts of the universe. Well, one of them is certainly that things are moving. So we do run into dilemmas when people try to deny an inescapable fact of the universe, and as much as we simply must take those facts for granted, there will always be those who deny them, and if they do so with academic integrity and seriousness, they deserve to be considered. So that's precisely what we'll do. So Zeno wants to prove that there is no motion, because he wants to prove there is no change, and motion being the most obvious form of change. Let me just close this. So his paradoxes, without further ado. I'm not going to go through all of them, but maybe just two of them. He has his arrow paradox, and he says an arrow supposedly moving through the air it seems, going at a great speed. So suppose that my piece of chalk is narrow. So it's hurtling through the air towards its target. And let's say that takes 2 seconds for it to go from the archer to the target. And then we perceive motion having transpired over that course of time. What about if we restrict the course of time to 0.2 of a second? What has the arrow done in that course of time? It's gone just a small portion of the distance. What if we restrict that to 2 milliseconds? It's gone barely anything. What if we restrict that to an instant? In a given instant, in just an instant, what is the arrow doing? Is that perfectly still? But Zeno says, look, time, all things that happen throughout time are simply none other than the sum of all the individual instants of which that span of time is composed. But if there is no motion in any given individual instant, then how can there be motion in time at all, which again is the sum of these instants? It's all an illusion, Zeno says. And he didn't have access to an analogy that we have access to today that he would jump on immediately as a perfect illustration of his point. Something we all see every day, probably far too much every day, probably far more than we should every day, where there seems to be things moving, but it's a pure illusion. It's right. Okay, there's a good point. I didn't think of that. Like the relative motion, your motion relative to the things you observe when you're driving, it seems to you that they're moving. That's interesting. What's even more illusory?
Screen.
Exactly. What's happening on a screen that seems to be motion? The pixel, yeah. You're just, when you're looking at anything moving, let's say you're watching a movie of an arrow flying through the air. What is causing the appearance of that motion in the screen? Yeah, 30 perfectly still pictures flash before your eyes each second. And your brain fills in the blanks and perceives it as motion, but of course it's not. There's no actual motion on a screen, it's just a bunch of still images. So, very interesting point. Another paradox, he has more, but I'll just talk about one more, is his, it also pertains to an arrow or anything moving, but anything that is approaching a destination. Let's say I'm an arrow, or let's say I'm not an arrow, let's say I'm a person, and I want to walk somewhere, so I have to move to that place. Well, in order for me to get to the door, I have to first traverse half the distance to that door. And then I have to traverse half the remaining distance. Then I have to traverse half the remaining distance yet again. And then still again I have to traverse half the remaining distance. What's the problem here? I'm never going to get to the door. Why? Yeah, there's always going to be half a distance remaining for me to traverse before I can arrive at the door. So I'll never arrive at the door. We're going to be stuck in this classroom forever. We'll never be able to get to the door because of Zeno's paradox here. Of course, we can get to the door. So how do we respond to Zeno? Or do we believe him there is no motion? I'm not going to begrudge anyone for just saying, Zeno, you're being ridiculous. Go to sleep. Go take a nap or something. That's fine, because that's so ridiculous that sometimes, for the sake of time, things must be dismissed. But there are good actual rebuttals to Zeno. One of them would be with using calculus, actually. If even an infinitely extending curve here, as long as it's exponentially decaying and going half, that's an example of exponential decay. Does anyone recall? You can take the integral, meaning finding the area under this curve, which would correlate to how much distance you have to actually travel. And if you took the integral of this from 0, even all the way to infinity, what would you get? A finite number. It seems strange, but it's true, is that an infinite integral can yield a finite number. So yeah, you have to go half the distance each time, but it actually still adds up to a finite number. So no, you don't have to keep going forever, Zeno, but more, that's a mathematical response, and that works, but I think just more basically, philosophically, we run into great problems whenever we refer to continuums as the mere sum of individually non-existent points, because that's not what they are. They're more than that. A continuum of any sort, whether it's time or space, there's more to it than merely adding up the sum of infinite points. Because a point is what? Has what? Has no what? No dimensions at all. It has nothing, it is just a location. It has no part to it. It doesn't matter if you add up points for all eternity. You will never get even the smallest segment of anything. So it seems like a logically unjustified leap to say that any actual continuum of any sort is defined as the sum of infinite points. But sometimes we do that, and it's not a good way to define, like sometimes in geometry, some geometry textbooks define a circle. Let's see if anyone remembers. Does anyone remember how a circle is defined in your high school geometry textbook? I don't know if yours did it this way, but I've seen some do it this way.
All points equidistant.
Exactly. The locus of all points equidistant from one given point. And that's a pragmatically useful instructional tool for tracing out a circle, but that's not what a circle is in its essence. In its essence, a circle is a perfectly round, closed curve, which is itself a continuum. I could keep tracing out a locus of points equidistant from this point forever, and I'll just have a bunch of points that is not fundamentally a circle. I mean, again, it's useful. It's a perfectly useful definition, but it's not a philosophically valid one. And that's not entirely a moot point, because if we define things invalidly, if we take a pragmatic definition and erroneously conflate it with a valid, logical, philosophical definition, then we're bound to fall into the very same trap Zeno did. We're going to extrapolate a mere pragmatic tool to try to use it to define reality itself, and that's contradicting which first principle? Well, that no effect is greater than its cause. All right, I don't want to spend too much more time on Zeno, as much as I would love to. He has other very interesting paradoxes. There are good rebuttals to all of them, but these rebuttals didn't really happen in his day. Aristotle answered well the paradoxes of Zeno and Parmenides, but they did kind of throw a wrench in these pre-Socratic attempts to discover the Urstoff, and perhaps, I can only guess, it took the wind out of the sails of the whole movement to some degree. Because Parmenides, his own lifespan actually overlapped that of Socrates. So we're getting to not so much be in the pre-Socratic era now as we are in the realm of Socrates' contemporaries. There's even a dialogue, a Platonic dialogue. And by the way, whenever someone refers to a Platonic dialogue, that's a dialogue of Plato, but it's always Socrates speaking. Socrates is the character in all of Plato's dialogues. He's a real person too, but he's the character that Plato writes through also. That's a whole can of worms that maybe we'll open a little later. So I think we can be confident that there is change and there is motion, as much as Zeno wants us to believe there isn't. And we can move on now to our next pre-Socratic, Empedocles. Empedocles is another one who doesn't get enough credit because he seems to be another retrogression. He seems to be going back to the previous attempts to simply ascribe some visible thing to be the Urstoff. But he actually gives us a great advance because he is no longer a monist, but a pluralist. In other words, he does not believe there is only one fundamental thing, but what? Many. At least multiple. In fact, it is Empedocles, it is in the writings of Empedocles that we first see what just about anyone would say who knows the answer if asked, what are the traditional four elements? And what are the traditional four elements? Exactly. Earth, air, water, fire. You might say, well, hold on, he's just stealing the Urstoff from three of the guys before him. Well, no, he's not stealing anything. He's saying, look, they were right, but they were right in a sense, but multiple substances are irreducible. The pre-Socratics before him were largely saying there must be absolutely and only one ultimate substance underneath all substances, that at some point, underneath all apparent substances, I should say, that at some point, they would all reduce down to some basic Urstoff. Empedocles is saying, yes, there is an Urstoff, but it is multiple. There are four things that cannot be broken down any further. In other words, elements. So this idea of having multiple elements, we have Empedocles to thank for. And he's actually, the very last pre-Socratic we're going to talk about is the one who gets all the credit today. And understandably so, he's certainly onto something. But Empedocles deserves a little more because of this idea, which is largely what we would say today. Now you might say, well, hold on. The elements can be broken down. Well, yes, they can be, but for all intents and purposes, 99.999% of the occasions any of us will ever be in, they can't be. Unless you want to go into nuclear engineering, which is fine if that's what you want to do, but in extremely few cases is it even relevant to consider an element being broken down. For almost everything you'll ever have to deal with, even in engineering, in science, elements are irreducible. You know, by elements I mean what we now know to be the dozens and dozens of elements on the periodic table. Those can be basically considered to be elements, and that Empedocles Didn't exactly get all 92 of them or all 100 whatever we've made in the lab, nor was he exactly right in the individual ones, but he was right on that there are multiple of them, that they are more or less irreducible. So this is a big insight, but it's not even his biggest. His biggest insight is that there are not only elements, but there are also there's not only fundamental matter, there is also fundamental what? And we're talking about the corporeal cosmos here, not anything like supernatural or anything like that. But the corporeal universe has fundamental matter and... Close? What's that? Yeah? In what? Space, okay. So with this big vat of space, we've got irreducible types of matter, and what else must be considered within this space and the matter that inhabits it? Yeah, forces. He also says there are fundamental forces at work. And that's exactly what we would say today in modern physics, that there is indeed matter, but there are also forces which are distinct phenomena from matter, and yet they are corporeal and real, and they exist. We speak of four today. You all know the one that we're subject to most frequently, gravity, one of the four fundamental forces. Then there's electromagnetism, and then the less popular ones, but just as important, would be the strong and the weak nuclear force. So we speak of four fundamental forces today. Well, Empedocles is very close in saying the fundamental forces, but for him there were two. And you're going to laugh, maybe, at least inside, when you hear what they are. These material substances are acted upon by two forces. Love and strife. They are the fundamental forces of the universe for Empedocles. Love and strife. I want to read a little excerpt from Copleston explaining this view of Empedocles. Empedocles speaks of these things as the roots of all. He doesn't use the word element, or even in Greek, but he says they are the roots of all. We have this cycle, this universal cycle due to love and strife. These two forces are always duking it out. And he means this literally, by the way. He's not just saying these are these metaphorical ideas. Like there's literally these elements literally love and hate each other. And sometimes love is winning out and sometimes strife is winning out. When love reigns supreme, the whole universe is condensed into this single mass, this single point. And then strife enters in, and it enters in more and more and more, and the universe expands and expands and grows more and more apart because of strife tearing things apart. But then eventually what happens? Love starts winning, and it starts pulling things back together. And this actually sounds astonishingly like what some physicists would refer to as Big Crunch theory, although that's not actually agreed upon as the correct theory today. The heat death of the universe would be the more accurate theory regarding the fate of the universe. But still, very interesting what Empedocles is onto here. Let's see what he says. According to Empedocles, the world process is circular, in the sense that there are periodic world cycles. At the commencement of a cycle, the elements are all mixed up together, not separated out to form concrete objects as we know them, a general mixture of the particles of earth, air, fire, and water. In this primary stage of the process, love is the governing principle, and the whole is called a blessed God. Hate, however, or strife, is round about the sphere, and when hate penetrates within the sphere, the process of separation, the disuniting of the particles is begun. Ultimately, the separation becomes complete. All the water particles are gathered together, all the fire particles, and so on. Hate reigns supreme, love having been driven out. Yet love, in turn, begins its work, and so causes gradual mingling and uniting of the various elements. This process going on until the elemental particles are mixed up together as they were in the beginning. Very interesting. This strife entering in this homogeneous mixture in the beginning. And we look about now and we see all of these elements separated out. We see big expanses of water, expanses of air, expanses of earth. And whenever the Greeks refer to expanses of fire, they're referring to the heavenly bodies, whether it be sun or stars or moon. So where are we in this process now? Is hate continuing its work, or have the tides turned for the sake of love? Well, who knows? But either way, it's at least fun to read about. Empedocles was also, like Pythagoras, an interesting fellow. He was a little more than interesting, actually. Sometimes, I have to admit, interesting is sometimes the word that I use when I can't think of a nice word to say, and I think we all do that. Oh, that's interesting. I don't necessarily mean it negatively, but Empedocles wanted to be worshipped as a god. The legend goes that he wanted to be sure that no one could find his body after he died. He wanted people to believe that his body was often Mount Olympus with the other gods, Mount Olympus. So one surefire way to get rid of your body, if you happen to live in the area he did, was to jump into a volcano, which apparently he did. How do we know he jumped into a volcano? Well, because his whole plan was that we wouldn't know. But apparently his shoes fell off right before he did so, and they found his shoes right there at the edge of the volcano and rightly concluded that he jumped in. So sorry, Empedocles, you're not a god, but you are an interesting guy with some good ideas. So we are making advance, actually. Believe it or not, Empedocles represents an advance. And we now turn to Anaxagoras. Major contemporary now. Anaxagoras wasn't even that much before Socrates himself. And Socrates, as you'll see in the next reading, the Apology, Socrates was much exposed to the writings of Anaxagoras and much appreciated some aspects of them, but was disappointed by others. Anaxagoras could have been a real bridge between the pre-Socratics and Socrates, because he had an intuition that took Heraclitus' notion of the logos even further. But he didn't do much with that intuition. Before we get to that, let's take a look at Anaxagoras' physical Urstoff. Copleston points out, and by the way, for those of you who weren't here before, I have this book, A History of Philosophy. Frederick Copleston is one of the most highly respected historians of philosophy, and he wrote a whole big volume set, including a major volume on ancient Greeks, and I like to quote him from time to time. If I'm quoting somebody on these Greeks, unless I say otherwise, it's probably from Copleston, Frederick Copleston. Heraclitus, if you were here last week and saw the movie, you might recall that he was a great patrician, one of the great leaders of Athens right before Socrates' day. Heraclitus himself was a student of Anaxagoras. Anaxagoras was brought to trial by the political opponents of Heraclitus later. This often happens. We'll see when we get to the Aristotle unit that almost happened to him. A great ruler dies, and then his political opponents are able to flourish and stir up opposition to his legacy, and those who are associated with that person are majorly persecuted. Does anyone know who Aristotle was largely associated with? Who his most famous student was? Yeah? Wait. Oh, not Democritus, but someone even bigger name still. Not a philosopher, though. Alexander the Great was a student of Aristotle. It's crazy how history works. No one would ever guess that one of the greatest conquerors in history just happened to be the student, one of the main students of probably the greatest philosopher in history. But anyway, that's how it works. So we start with Socrates, who just kind of exploded out of nowhere and founded philosophy practically. And then Plato is his student. Aristotle was Plato's student. Alexander the Great being Aristotle's student, but we don't exactly have philosophical writings from Alexander the Great. As great as he was, I don't know if everything he did was good, but that's a debate for a history class. A debate I would be quite unworthy of. Anyway, back to Anaxagoras here. Anaxagoras has this idea that there are no indivisible particles, but that matter is infinitely divisible. And the key in distinguishing what types of matter there are is identifying what things remain what they are when they are divided in half, or divided however. It's fairly easy to see what he's talking about. So there's a thing called dog. There's a thing called dog nature, dogness. I don't think any of us deny the existence of dogs. If you took a dog and split it in half, what would it be? Would it still be a dog, or it would be half a dog? It would be kind of a sorry sight, wouldn't it? It would be a corpse of a dog. We wouldn't call it a dog anymore, because dogness is not one of these substances. But Anaxagoras says anything that, if split in half, remains itself, must have something called seeds. And these seeds are physical beings that are infinitely small, and therefore, because they are infinitely small, can be found in everything. Anaxagoras, I don't know how else to say it except by saying this. He says everything is in everything. He says basically you observe things becoming other things often. But how could one thing become another thing if that other thing was not already in it? And Aristotle will have a much more accurate notion on this later. Aristotle will point out it must be there in potency, but not in act. The distinction between act and potency, form and matter, these Aristotelian distinctions are really necessary for figuring out the various puzzles the pre-Socratics present. But again, we'll save that for the Aristotle unit. But Anaxagoras is onto something, even if he's wrong in the details. He says everything is in everything, and this is possible for him, for his theory, only because matter is infinitely divisible. You couldn't practically have everything in everything if there is the smallest particle, because there wouldn't be enough space to have everything in everything. But if matter, if the atom itself could be split into 1 trillion smaller atoms, and each of those could be split into 1 trillion smaller pieces, then yeah, you'd have enough space to fit everything in every little piece of everything else. What specific profession took inspiration from this idea? It flourished in some parts of the medieval times. Because if everything was in everything, what would you really want to be sure you got out of a hunk of iron, maybe? It would be really nice to be able to squeeze out of a hunk of iron. Yeah. Oh, did you say gold? Yeah, alchemy. Alchemists were always trying to squeeze gold out of other substances. If only they sided with him a bit on that, they wouldn't have wasted their time. But anyway, there's still good reasons that Anaxagoras had for believing this, and I think one of them, no doubt, would be an example of how all of us are generated. Look back in your life far enough, there was a time of, I don't know, a year or so, where you grew flesh and blood and bone and hair and all the thousands of other substances in your body with only one input substance: milk. And it's you know, obviously we now know, sure, there's just thousands of nutrients in milk, and your body can take the pieces and combine them together amazingly. But still, you look at that not knowing all the biological details, and it makes sense to consider, wow, milk must have everything in it. But why just milk? Well, maybe everything has everything in it. Maybe the seeds of every substance are contained within even the smallest part of every other substance. And that's what Anaxagoras says is indeed the case. Everything is in everything because of this infinitely divisible mixture of particles. He has major cosmological speculations regarding how these particles work, how these actualities are recognized from these mixtures, because obviously there are differences in things. If everything is in everything, then why do we observe some things to be metal, some things to be stones and wood? Well, he has a theory on that. He says, in the beginning, particles, there is no indivisible particle, are all mingled together. All things were together, infinite, both in number and in smallness. For the small too was infinite. And this is Anaxagoras, his own words, and when all things were together, none of them could be distinguished for their smallness. All things are in the whole, were in the whole. The objects, back to Copleston's words, the objects of experience arise when ultimate particles have been so brought together that in the resulting object, particles of a certain kind predominate. In concrete objects of experience, there are, according to Anaxagoras, particles of all things, yet they are combined in such a way that one kind of particle predominates. And from this fact, the whole object gets its denomination. Anaxagoras held that doctrine that in everything there is a portion of everything. But let's, kind of like how Empedocles had maybe a more profound notion than his material Urstoff, same thing with Anaxagoras. Anaxagoras was the first pre-Socratic to really say that by merely describing the material aspect of a thing, the material cause of a thing, you are not truly grasping the thing. The real question is what its form derives from. The real question in describing anything, even a material thing, is the description of the genesis of its form, the significance of that which makes it what it is. And the mere matter of a thing is not that which makes it what it is, but it is that which gives the potency for it to arise in time. But what acts upon that potency of matter to generate a given form out of it? Well, Anaxagoras introduces the idea of nous. Let me just draw a line here to make sure you know that this goes with Anaxagoras here. He calls this the divine mind. He's taking this idea even further than Heraclitus, who says there is this logos, this mysterious reason and order behind all things, that both orders things and places demands on beings with reason. Anaxagoras says that's a literal mind. He calls it nous, though, and this mind orders things. He says it is infinite and self-ruled. It is mixed with nothing, but it is alone by itself. It is the finest of all things and the purest. It has knowledge about everything, and it has the greatest power. And Anaxagoras has this idea of all of the cosmos spinning around in this vortex, kind of like Anaximander before him. And that this nous has power over all things that have life, both great and small. It has power over the whole revolution of the cosmos, and it began the revolution of the cosmos. But we can't say much more about Anaxagoras without just reading things into it, because he didn't say much about the nous other than that. And that's precisely what we'll see later Socrates was disappointed by, that he didn't take this idea any further. He just kind of introduced it to get this idea going, get to say, at least nominally, how things might have operated. But he didn't analyze it at all. He didn't dive into the details of, okay, how can we understand then what is true and good and right in accordance with this overarching principle of the nous. He didn't do that. He didn't apply it to life very much. But that's where Socrates picks up. But before Socrates, we have one more, Democritus, the famous Democritus. Let me do some erasing here. And I'm sure, as you all rightly assume, there are many other pre-Socratics, but for the sake of time, we can only cover a number of the more common ones, more commonly known ones. Democritus is often associated with another pre-Socratic called Leucippus, but their theories are basically the same, so I focus on just Democritus. Some people argue there was no such person as Leucippus. It doesn't really matter. Democritus, as I think I mentioned earlier, says that everything is what? Maybe I didn't mention. Can't remember. Everything, well, kinda. Democritus is the one who gets all the credit today because he says the most fundamental essence, everything materially is atoms, the atom. So at this point, everybody perks up and says, finally, somebody gets it. Democritus is my man. And yes, he deserves much credit. But maybe not as much as he gets. First of all, the very word atom, atom, indivisible, means that what we call an atom today, we should really call a what? A molecule, maybe. We don't. We're not going to change our terminology, nor should we. It would be pointless. But technically, an atom is not, what we call an atom is not an atom, because we know it can be divided. And we have no, the question of when does the division stop is not itself necessarily a question of physics, it's a question of metaphysics. The world's best particle physicist working at the world's best linear accelerator over at CERN in Europe maybe, he can't say, he has no, as just an intelligent human being he might be able to say, but as a particle physicist he has no grounds for saying that this particle that we've now discovered is the smallest. Maybe the smallest we've yet discovered, but anybody off the street could validly say what to that? How do you know you won't split that one tomorrow? Exactly. So it's not like, it is and I'm not condemning science at all here. Any scientist worth his salt would admit that the very cornerstone of the scientific method is falsifiability. That's a given proposition, a given theory doesn't even qualify as scientific if the one proposing it has not put forth a scenario under which it could be falsified. Because if something cannot even theoretically be falsified, it's not worthy of its of having a scientific proof for it either. Maybe a logical proof, but not a scientific one. Anyway, didn't mean to go into that digression. Let's talk about Democritus. So Democritus says everything boils down to either atoms or void. He has an absolute binary view of material reality. There are only two things that can be said about existence: atom, void. Nothing else can be said about existence except atom, void. So he is the ultimate reductionist. Everything that we observe is a mere consequence of the interaction of atoms within void. The void being just space, vacuum, the nothingness in which atoms move. Now, as much as he's onto something about atoms existing, he also misses out in a lot. And if we recall pre-Socratic just a couple lines up, what is the main thing he's missing out on here? The existence of, what's that? Well, yeah, there you go. You certainly didn't know about electrons, and electrons are especially associated with energy and forces. There are no forces for Democritus. Because a force would be a phenomenon fundamentally distinct from the phenomenon of atom and void. So it's inadmissible in his theory. There can be no forces. And yet, for a theory to be helpful, it's got to explain what we observe. That's why we make theories, to try and figure out what principles govern the things that we observe. Well, what do we observe about atoms? Some of them hold together real strong. Like this is pretty strong here. There's a bunch of atoms and they don't want to be separated. Why not? If it's just a bunch of pieces sitting there, why can't I just take a chunk and just rip it off? Well, I mean, maybe if I really tried, I could break it, but it'd be very difficult.
There's carbon bonds, there's hydrogen
Bonds, exactly. And the bonds are what?
very strong attractive
Forces, yeah. The only reason these atoms can have any sort of coherence to them and not just be this infinitely dissipated gas and there being nothing else is thanks to forces. Now Democritus realizes that. He realizes he needs something in his theory to explain the fact that some atoms stick together in solid substances, some don't, some form liquids and gases. Well, his atoms are not like our atoms. His atoms are not these point masses, they're not these electron clouds swirling about a nucleus, they're not even spheres. If you were Democritus, how would you, if all you had were atoms and no forces, try to explain some material things holding together and some not? The atoms are not mere simple spheres, they're like Velcro. It's fascinating, his thesis. It is only due to the geometry of individual atoms that some tend to hold together, like Velcro or like jigsaw puzzle pieces, or like, anyone have those monkey games when you're a kid with the monkeys that you pick up with other monkeys? I can't remember what it's called, but what is it? Barrel and monkeys?
Barrel of monkeys.
Barrel of monkeys? Glad I know. I gotta get one of those for my son. I remember that being fun. So some atoms are like barrels of monkeys, and others are like the noodles I tried to have last night that I couldn't even eat because they were so slippery. Like my niece made them. Faux noodles, I think they're called, some sort of Asian noodle. They're small and so slippery. I couldn't even pick them up with my fork. I just had no idea how to do it. So we've got noodle-like atoms, we got barrel monkey-like atoms, Velcro-like atoms, and the geometric configuration of the atoms determines how they do or do not hold together for the given object. But also, there's something else majorly missing in this account. How do we observe, like, how are you guys able to see anything right now? Because of what? Light, which is, oh, now I'm going on another tangent I should not. Exactly, it's an energy, it's a force, it's vibrations, electromagnetic waves. Those are forces. Democritus knew that we could see things, but for him, the sense of sight then was basically comparable to what sense, to what other sense? The operation of sight operates like the sense of smell, because there are no forces, so you can't interact with something over space except through the exchange of atoms. When you're smelling something, you are literally receiving its atoms into your nose, but you're not when you're seeing something. You're just the force, the waves are bouncing off the thing, and you have no material interaction with the thing you're seeing. So as much as, yes, he does deserve credit for saying all things are atoms, he actually misses a lot more than he gets. So I want to give him all the credit is due, but not more.